as you said, this marine structures are of national importance. We have like ports, bridges coming up to the coastal areas are experiencing or exposed to very harsh environment. India has a very long coastal line, and this line offers us a lot of challenges in construction of especially the concrete in the marine environment. The of late we are coming across a word for durability. In construction, for a long time, we were focused mainly only on the compressive strength of the concrete. We were happy that our strengths are getting higher and higher. But of late, because of certain accidents and issues, especially as we are discussing today about the marine environment, the durability is coming to the prominence. What is the durability? The service life of the structure is reduced because of certain issues in the structures. Say, for example, concrete is the reinforcement what we use, especially through marine perspective. The reinforcement gets corroded earlier than expected because we have not considered certain things during the construction or in the design phases. So what is the difference between the concrete, what we use in marine structures and what we use in non-marine structures? As I said in the opening remark, the durability is more pronounced in the marine structures as, the effects of a lot of harmful effects of environment plays, havoc in the concrete if not taken care of. Now, what exactly are the issues we face into the marine concretes or structure for that matter? We get exposures to chloride and sulfate. See, when you say marine, it's basically coming in contact with the seawater as a general statement. So what the seawater is not a concrete-friendly atmospheric material, our exposure. It carries a lot of chloride and sulfate, some gases, or maybe algae and funguses. So what happens when this chloride and sulfate attack happens on the concrete? If the concrete is not permeable, it is concrete is porous, and then this chloride enters into the concrete through pores and get cracks, etc., and attacks the reinforcement. Reinforcement being metallic and iron material, it gets corroded. When the reinforcement gets corroded, it increases into volume, exerts pressure on the surrounding concrete, and concrete gets cracked or spoiled under extreme conditions. So this is the basic issue, which is because of the chloride ingress. Sulfate also increases attacks the concrete, and then carbonations are other things which are affecting the concrete. So what happens when we talk about marine? We have to take care of certain aspects of the design, choice of the material, workmanships, etc. Let me talk about the composition of the concrete for marine purposes. Since we talk about durability, we have certain performance requirements in terms of tests. Of late, we have seen some durability tests being recommended in all the specifications, like rapid chloride permeability test, water absorption, water penetration, etc. And a new test been introduced in one of the projects in Mumbai, and I see it is getting repeated in a few other projects as well. We have a project called Mumbai Trans-Harbour Link, which is renamed as Atal Setu in Mumbai, which is built in sea, and another coastal road where a new test has been recommended as the rapid chloride migration test. So these tests are been very tough to achieve or pass or comply with. It needs some specific choice of materials which enable the concrete to perform well in terms of passing the test, which in turns are, perform better in marine environment or very severe exposure. See, if you talk about the relevant code, say IS 456, which gives the exposure condition, the marine falls under very severe or extreme cases of exposure. where we need to, as per code, we have to maintain certain minimum cement content, and the water cementitious content ratio has to be limited. So when we use or when we design concrete for such conditions, for compliance with the codal provisions and compliance with this new test for the extreme conditions, we have to use not just cement, but also we have to use pozzolanic materials like fly ash, GGBS, superfine material like microsilica, etc. Nowadays, even superfine fly ash, superfine GGBS, etc., are also being introduced by the vendors and the industry. And good thing is it has been covered under the relevant separate IS code as well. So what happens when these materials are used in the concrete? Concrete gets certain properties which are not, achievable by only cement. So concrete become more dense. It gives a very dense matrix, and this chlorides and sulfate, etc., exposures are, withstood very well. Nowadays, also, if you go by the example, this as I told you, this MTHL, Mumbai Transfer Link, Coastal Road, they're all directly been exposed to seawater. So when you talk about exposure to seawater, this material which we discussed just now are mandatory to have a good service life, and also to as an idea of performance, this test which have been recommended or specified, it's easy to comply with. Now, what this material? Sometimes we use a combination of cement plus fly ash and say microsilica or superfine materials, which is coupled with special admixtures, because when you make use of this fine materials, concrete becomes sticky and is a bit difficult to handle in terms of pumping and other things. So we need to use special admixtures which will reduce the density, viscosity of the concrete, and also been user friendly for the site people to place, compact, and finish. So special admixtures are also come in picture. When we talk about the reinforcement, which is a material of focus, because it gets corroded. So this material are specially selected corrosion resistant steels, and many times it are coated with fusion bonded epoxy material. People must have seen green color of reinforcement being used in some of the bridges and the structures. So these are some of the measures being taken. And once you have built the structures are exposed areas are painted with anti-carbonation paints to protect the concrete from, the threat of outside atmosphere. See this. There are a lot of workmanship matters also in such cases. We have to compact it well. We have to cure it properly. This goes without saying, because these are general workmanship aspects for any construction, but also holds good, rather made it mandatory for the marine structures, because we need to have our concrete to be viscous. The reinforcement, as I said, is of the focus. The cover of the concrete through the reinforcement, which is on the edge, on the outer side, need to be wide enough and strong enough to protect the reinforcement. There are codal provisions during the design. Extreme cases, it goes up to even 75 mm, and this needs to be very strong so that it can cover and protect the reinforcement. In future, maybe since this material technologies are getting evolved day by day, I would be more interested to see the industry doing investing into R&Ds for the protection to the concrete in terms of the paints or coatings which are coming on the surface, like some polymeric liquids which can be applied, and also use of nanotechnology in it, etc., which will enhance the surface protection of the concrete and increase its service life. Because I believe strongly that repairing concrete is a very costly affair. So it's better to protect in all possible ways, right from the design stage till the end of the construction process to protect the concrete in all possible ways, as we discussed just now, and do some R&D for extra protection. Thank you.